Okay, trying something a little bit different today. I have some RG-174U coaxial cable that I want to use as a feed line for doing low power radio in the field, QRP, field day type stuff, or parks on the air, etc. And I've been putting off doing anything with it for a while because I haven't really needed it, but now I kind of need it. And I got solder type connectors, and I didn't find a good guide out there for how to solder RG-174U to RG-174U type BNC connectors. And there aren't even crimp guides that I saw for 174U. Most of it's for RG58 or similar. So I'm going to try and make a guide while I do it. So first let me lay out the pieces that came with my connectors. So I got a couple of these. I got them from the RF Connection. I'll link them below with the part number. But what's included is the main connector housing, which I have fully disassembled, the rear nut, a rubber spacer, a metal conical piece, and it's slightly larger on the bottom at the flared out part of the cone than the top, and a washer, a little plastic spacer. This does not have a cup. Some of the larger ones for like RG58 and such have a cup. This one does not. And the brass center pin itself. And then the additional tools that I'm using, I have a utility knife, wire strippers, soldering iron, some solder. This is relatively small, 0.32 or 0.032 diameter. Pretty fine. Any fine solder with resin should be fine. A wrench for attaching the rear nut, soldering iron. I think I already covered that. So there is a pretty good guide video that was made on soldering a BNC connector to heavier coax. Like I said, I think it's RG58, and it's very thorough. And I watched it prior to this, and I'll link it below. But it's pretty different. The included components are different, and some of the steps I think are different. So I haven't found a guide for how to do this. I've searched around. I'm sure one exists somewhere. So what I did to start was I went ahead and put on the rear nut, and then in other videos there's a washer that goes here. I think since this has a flat face, a washer isn't needed. Then the little rubber spacer, I just went ahead and slid those down. And then I believe that the next component that's needed is this conical bit. So I think what I need to do next is strip it, strip off the outer jacket, flare out the braid, and then, so I'm just going to do a little bit extra here. So strip off the outer jacket. Okay. And then let's see. I'm not sure if this should go at this point or next. I don't really like to guess about these things because I know that there's a correct way in which it should be done, but there just isn't any documentation. Or at least if there is documentation, I haven't found it. Alright, so what I'm going to do, I'm going to spread out the braid. I'm pulling it down, and then it's useful to have a fine point object like a 0.5 millimeter mechanical pencil here that you can sort of slip into the braid to unweave it, because otherwise if you just push it down it'll get kind of tangled up. But if you do this, you can get it pulled out straight. so it doesn't bunch. We're going to, of course, trim almost all of this off. We do not need it. Alright, so we've got that flared out. And this will slide down just fine over it. And then I believe we'd want this washer. And then I'm just doing kind of like a dry fit. And then the spacer. And then we'll have to trim this down a bit. So then we'll fit on the actual center pin itself and then solder it. But like I said, I'm not sure what the best place for this washer is. And now that I look at it, I actually think that the best place for this washer is probably on the other side of the flared out braid. So let me pull off this plastic spacer. Oh, don't roll away, buddy. Pull off the plastic spacer. Pull off the washer. Pull off this conical guy. Put the washer back on. I should be able to slide it down over this braid by folding it back. Oof, maybe not. Not if it flares out. Fitting it over the jacket is pretty tough. Maybe if I go the other way, maybe if I pull the braid back up and then and to wiggle the washer down over it. Okay, so now I've got it set up. Nut, rubber spacer, washer, and then let's flare out the braid once again. And some types of this small diameter coax have a foil in them as well. I think maybe RG-179 does, which might be the 75. See, yeah, doing this now pinches the braid between those components, and then since this is a flat top, I think it'll be fine. And it's hard to tell, but I think that sort of, I'm not sure if I can show it. In here, there's a what looks like a sloped surface inside of the BNC connector that is probably the same angle of this slope. So I think you want this to be the frontmost. Then the plastic spacer, I can drop in the plastic spacer and show where it'll go. He'll fit right down in there, I think. And then the pin actually sits on top of that. So we've got this squished down. Oh, and I realized you need a tool to trim these too, so I'm just going to use some edge cutters. Scissors also work very well for cutting this braid. Edge cutters sometimes struggle with how thin it is. Often don't get a good bite, but if you give it a little wiggle, it'll come out. You mostly just want to trim it all off, or trim off enough such that it doesn't get tangled in the threads. And of course you don't want it to potentially short out with the center conductor. But we've got it nice and squished down. We still have plenty of braid down there, so I think that's fine. And everything's pressed down. I kind of wish I had a little, oh, I can use forceps for this. What I'm going to do is I'm going to use a pair of forceps to clamp, though I don't want to clamp the cable directly because I don't want to damage it. I will clamp it through about an old ribbon cable. So that I'm doing this for, I'm going to clamp this assembly, the bottom part pushed all the way up, so that when I'm working on the top, it doesn't slide down. It really doesn't matter, but the reason I want to clamp it is so that I know exactly how much material I'm working with here. So then we drop on the insulating ring. That's about 1/8 of an inch tall. So I think I want to cut off at least half of this material. And then I'm going to strip it and tin it. You know what, I wonder, here's an easy test. Yeah, I think, so you can see that's just the core poking straight through. I think this is right. I don't want to screw it down because part of what screwing it down does is it causes the rubber spacer to balloon out and sort of lock things into place. So I don't want to do that yet. Let's put the core back. And then let's trim. Oh, come on, gosh, these clippers I think are toast. Yeah, this is an old pair that came with a 3D printer many years ago. I'm going to remove, well, actually, let me put the, where is the white spacer? Oh, did I lose him? Did I knock him on the floor? You probably saw that happen and I missed it. Oh, it's in the, oh no, it's in the thing. It's in the connector. You're not ready yet. I've got some teeny little tweezers. So this is tools that you should have if you're going to be attempting this and you have no idea what you're doing. Okay, there we go. So don't push that spacer in there until you're ready to actually assemble it, because it might get stuck. Oh, now I think I maybe trimmed off too much because I forgot about the spacer. Oof, that is not a lot, but you know what? I think that's enough. All right, so I'm going to trim that last little bit. It's just another 1/8 of an inch maybe. I'm going to use my handy dandy Klein wire strippers here. Pop that off. And then an added bonus of the forceps too is that this kind of holds it up in the assembly process. And I'm just going to tin this wire. This probably is overkill. It's probably a step that's not really needed. All right. There we go. That's tinned. And that, my iron, I said before, it's a Pine-Sol, and I've got it set to 600 Fahrenheit. All right, and then again, drop this guy on there, and I want to sort of lay this over. I'm going to lay it on its side like that. And I want to put something heavy here. I'm going to put a can of contact cleaner right on the edge. So that's, and I'm going to just lightly push down. I can see the center core through the pin, through the pinhole rather. And now I have to kind of think about how I want to apply solder to this. So let's get some heat going.
I know that I don't want to scoot it off like it's happening now. I want it to stay in place. I'm going to sort of give it a little bit of pressure. I'll throw down just a little bit of solder. I don't know if that went in the hole. And I have some brass wool on my soldering stand that I'm going to use to keep that clean. So let's take another look here. Oof, that is hot. I wonder why. Huh, that's crazy. In the video that I'm going to link in the description, he uses some desoldering wick to clean off the pin. I'm not going to do that because I don't want to risk pulling any solder off of that center conductor. Okay. But it feels nice and tight. I feel like that's a good bond. All right. So now this looks good. As far as I can tell, all the components are in place. So again, we have the nut at the rear, then the rubber spacer, then the washer, then the cone with the smaller part of the cone at the top, the larger part on the bottom. The coax is stripped right at the RG-174 is stripped right where that bottom washer is, and then I've got the braid pushed down and trimmed right above the or right at where the cone is. So there's only insulated center conductor going through the cone and the plastic spacer, and then right about at the top of the plastic spacer I stripped off the center insulator, and then I slid on the pin and I applied solder through that hole. So that's kind of the order of operations there, as well as, you know, how things are stacked. And then here's our BNC. You slide it down, and this feels tight. Like I can't push it beyond that. I'm not sure where. So it's getting this far. So how far in is the pin going in that far? That feels super close. I think I can thread this in here and it just fits down tight. I think it just fits down tight. One thing I don't have that would be very beneficial is a flat wrench that can be used to hold the body, of the connector. Let me switch hands here. Wow, that is just absolutely not happening. What on earth? Okay, time to grab the other one for comparison. And specifically, what I want to see is how far in does the cap nut need to be in order for those threads to engage. Okay, so right about here, this is the threads barely engaged. So I need to really squeeze it. Let's do that. I'm wondering if I have something wrong here, but it's just, this is the only way it goes together. I mean, this is the way that seems to make the most sense. There's a chance, let's see, I will try and use my side snippers here to shave off a little bit of the solder. I shaved off a smidge. I don't think that's what's holding us back, though. I mean, this has it going this far. I don't think the pin is the limiting factor. And the other thing is, I don't even know if this rubber spacer can be compressed as much as they want it to. So I'm taking a slightly different approach here. Maybe it is the center pin. So what I've done is I've just pushed the nut farther up the cable. And I'm going to see if I push on the rubber thingy. That might have worked, actually. I mean, I definitely pushed it forward. The other thing I can try and do is use the forceps to pull the pen forwards, but that, I think, is where it's supposed to sit. Here I have another BNC, and that looks right. The pen sits just level, pretty much, with the inner conductor and slightly lower than the outer shield. So, is that enough? Did I push it at all enough to engage the lock? Oh, and now the threads go in. So it might have been that little bit of whatever you want to call it, that little bit of solder on the pin. Yeah, not surprisingly, this thing wants to spin pretty much free. So I'm going to hold the body of the connector. Oh, those are a little bit too wide, but I think they'll work. I just don't want to mar it. I don't want to mar it too much anyway. I'll probably mar it a little bit regardless. Wow, man, we're asking a lot of this little nut. There's one thing that can happen is if you accidentally crush the shield or the body of the connector, then forget it. It's not going to lock again anymore properly. But I think that's good. I think we can call this. Geez, if I could stop dropping everything. I'm going to grab my Nano VNA here and make sure there's no shorts. So we're spanning, so this is with an open wire, so that's expected for it to look kind of weird. But if I change my display, I want to see the Smith chart. Yeah, I would like that to be more of an outer ring than a spiral in, but also the coax is coiled up. But the main thing is it's not
shorted. I don't have an infinitely high SWR that would, would indicate if something was shorted. So I think what I need to do is just terminate the other end, and then go ahead and test it. I've got a dummy load. I think this is like a 10 watt dummy load, and make sure I get 50 ohms all across HF, which should be fine. So I'm going to leave that for right now. I'll probably come back when I solder the next pin, and we'll see if I can get that process to go a little bit more smoothly. Okay, I just finished assembling the core of the second one, and really the only thing I did differently that made a significant difference is that when I soldered the pin, well, two things. I found that the hole at the bottom of the pin is a lot smaller than I thought. I didn't look at it last time, and I tinned it and just popped it in there, and by chance it just fit perfectly. This time when I did it, it was ever so slightly too thick at the top, and so I had to trim it down a bit to get it to be happy. But more importantly, when I heated it, so I held it vertically, and I applied the tip of the soldering iron to the rear, and then I was able to fit my solder perfectly into the hole. And so there's just a tiny amount of solder, and very little, I'm not sure how clear it is on camera, but very little actually came through the hole. And I think it's little enough that the profile of the pin where it intersects, with the hole in here shouldn't be disturbed too significantly. So hopefully this one goes together a lot more easily. And sure enough, I just pushed and it went straight. I felt a tiny bit of roughness where that hole was first clearing, but that was really it. All right, so let me wrench on this a little bit and clamp it down some more, and then we will put the 50 ohm load on it and see how it does. Eventually I would like to put just put the meter in, the SWR meter that is, into like through mode and measure loss. I haven't experimented with that yet. And I'm just turning this just very so slightly. There's a lot of force involved, and again, I don't want to crush or deform anything. Okay, I think that's where that's just going to be. But now we have another nicely terminated BNC onto RG-174. And this is 50 feet, so I've got just a pile of it sitting on the floor next to me, but here they are. And now we'll put our 50 ohm load on one end and move that to the side so I know it doesn't get shorted on anything. And grab our DNA. And this looks great. And you can't see it. There we go. So this is sweeping 1 to 60 meg. That's higher than it even needs to be. I can, because I'm never going to use this into VHF. Stimulus, stop. Let's just do 22 meg. And this looks fine. It's not completely perfect. But in my experience, the only SWR cable, or the only coaxial cable that you're going to see a better sweep on, is going to be some like really swanky heavy duty stuff. For what I want to use it on, this is going to be just fine. So very long video for just how to put a coaxial connector on the end of some coax, but I found this to be kind of tricky, and like I said, I didn't find any guides out there, so hopefully this is useful to you, even if you just skip around to the useful parts.
One thing that you might want to do, I don't think it's necessary, and I'm not going to be hard on this one, so I'm not too worried. But you could get a couple inches of heat shrink, and you could probably butt that right up to the end of this, and maybe you'd have to kind of fiddle with it a bit, but I bet you could get heat shrink under at least, maybe a tiny amount, a couple millimeters under the nut, just to provide a little bit more strength there, a little bit more support. But again, I'm not going to be hard on this cable. I'm not too worried about it. Or at least I'm going to try not to be hard on this cable. But yeah, so there you go. There's, again, putting BNC connectors, solder type connectors, onto a piece of RG-174U. Thanks for watching.